Hello everyone, thank you for coming. I will introduce to you the SEAPATH project and how we ensure requirements in the project through testing process and continuous integration. But first, I will present myself. I'm a software engineer at Savoir-faire Linux, which is a French and Canadian company specialized in free and open source software. And we are expert in these technologies. And we offer our help to other companies that will need us on these technologies. We are a member of the Linux Foundation Energy, especially with the SEAPATH project I will introduce to you, of the Linux Foundation, and a silver member of the Yocto project. So I'll present to you the SEAPATH project and the virtualization for real-time power grid substation automation. But first, a bit of context. We're experiencing right now a real energy transition in the power grid, and we are switching from a very centralized network, very centralized grid, to a more distributed one due to different factors. First, we have more different energies in the grid with renewable energies, for example, and that means that before we had some big energy producer on the grid, and now we have many smaller points, many more smaller points, and renewable energies that doesn't produce the entire day the same amount of energy. But the demand in electricity have also changed with some, for example, the come of the electric vehicles. Many people need much more electricity than before, and with the Internet of Things, and we have again a big demand in this part of the sector, and that the grid need to adapt from a very centralized network to a distributed network, but also it needs to be much more dynamic and adaptable. We need to be flexible in order to respond correctly to the new demand in electricity. So that's the vision of the project at first. This is to move from to a software-centric power automation system. Right now, in the many substations, in classic substation, you have many pieces of hardware that comes from different manufacturers and that interact with each other, and we want to move from this type of substation to a very software-centric substation. That is needed to achieve the flexibility and the scalability we want to respond to the requirements that I described before, and that's totally fit into the open source model, as many people have already described to you during this event. Just a bit of history. The inspiration comes from the United States and the network industry with the UNAP project. They wanted to deploy the 5G, and they had the same problem as we faced on SEAPATH. And that's the kind of things the way they answer the problem. So the mission statement of SEAPATH is to develop a reference design for the substation and an open source platform that will run many virtualized protection application, each of these virtualized application will manage one piece of the hardware, one device in the substation. This platform needs to offer real-time performance and ensure many requirements such as safety, reliability, and many more I will describe just after. So this is the SEAPATH project for software-enabled automation platform on artifacts terrain. What are the requirements we have on this project? First, I already said that we need high performance with real-time, of course, and low latency. The communication between the different devices and different virtual machines we have to reach a very low latency for this communication. The center of the project is to be adaptable, as I said. We need to be highly customizable, to be hardware agnostic, so to be able to run off any type of hardware, and to be easily adaptable. We don't want, every time we have a software update to made, we don't want someone to come on the substation and plug the device, put the USB key, and so on and so on. So that's not the goal. And because we follow the open source philosophy, we want to follow the state of the art and integrate many open source components that already does some jobs we want to do really good. Today, the SEAPATH projects come in two main versions. We have the Yocto build and the Debian version. Yocto is more an embedded philosophy. We will build an entire Linux system with all the software and the kernel that we will describe. That gives us a very fine tune of the software and the version, the patch that we apply on our Linux system. And that provide all this information using the software bill of material with SPDX, which is today also a big requirement in the industry. On the other side, we have the Debian version, which is more an IT philosophy, and there's much more widespread among developers today, and that have no compilation. Yocto builds can be a bit heavy today. Here we have a visual map of what is the SEAPATH project. So, as I said, it is supposed to be a mainframe in the substation. So we don't we just have the basis of what run on the substation. We don't put anything on the VMs. That's to the manufacturer to do. That's the goal. So we use a Linux kernel, a real-time Linux kernel, to meet the real-time constraint. We have all the first part with Ceph and Pacemaker, which will be able to run VMs in a cluster of hypervisors. So we'll distribute the VM on different hardware, different hypervisors. OpenVSwitch is used to control a network between these hypervisors, but with a software approach, so we can update our network dynamically. The use of DPDK is optional. It's supposedly to be more to speed up OpenVSwitch, but we have many other technology to do that. That's the big point of discussion today. And of course, KVM and QEMU, which are the classic couples for virtualization on Linux. And as I said, again, on top of that, we have all the virtual machines with the functionality of the substation. SEAPATH today is a project of the LF-NRG, which is an early adoption phase. So we meet the silver badge of the OpenSSF best practice. We have the 20 repositories, 1,800 commits, and 700 tests that runs on the SEAPATH project to ensure that everything is run correctly. And with such a big project, if we want to meet the requirements that I described before, we have to run a complete CI on the project to ensure that every code that we develop meets all standards. And that's the big part I will describe yet with the SEAPATH testing project. First, I will describe the test scenarios. So as I said, SEAPATH missions is critical, and we have many points to meet, many requirements to meet in terms of reliability, of course, cybersecurity, which is a huge business in the energy, robustness, and low latency. And we have a test scenario for every of these cases. In fact, the robustness test scenario is not there today, but I will describe this at the end. First, in terms of reliability. The SEAPATH project is a bit different from others because all the functionality is in the virtual machines and that we don't create this functionality, we can do functional testing. That's the customer to do that, the manufacturers who have to do this functional testing. But what we can do is do a system-level testing to ensure that the platforms offer the VMs everything that we said, every requirements. And how do we test that? We test that with very simple test, very quick test, unit test. As you can see on the right, for example, just start a VM, see if it's okay, is the kernel the good kernel, is QEMU available, is the service running, and so on and so on. That's very little test, but with a huge amount of tests, we will be able to ensure that every part of the system is running and that we are reliable. In terms of cybersecurity, Today, SEAPATH ensures compliance with the recommendation of the ANSI BP28. The ANSI is a French organization for cybersecurity on information system. What the cybersecurity tests do is basically the same philosophy that the reliability tests, that we want to have a really simple test to ensure that we, for example, we have the minimal attack area. So we have to list every packages, every repositories, every services that are running on the system, and to see if everything is okay, if we have think of everything that is running on SEAPATH. We also check kernel hardening, service hardening, so you can see example of test on the right. Again, that's one test does not do big things, but with all the tests that we have, we ensure that we know what is running on SEAPATH, and we have think about all these aspects. And then come the latency test with the IEC 61850 compliance. There are both two types of tests in this part. First, we'll stress test the CPU with a cyclic test that runs inside the virtual machine to test the CPU itself. And after that, we want to run tests into the entire cluster and to test the communication between all the devices. So we have a sample value sender, which basically just a raw internet frames that we send into the cluster that will go into the hypervisor and in the virtual machines. And when the sample value is received in the virtual machine in user space, it is usable by the application that the manufacturer does. So the idea is a very, very simple case. If a capture said, I detected that something is not good, we have to react quickly. So we have to measure the time between when the capture sent this information and when it is available for an actuator to do something. Now that we have this testing process, how do we ensure requirements? How do we see that everything is okay on our project? We do two type of things today on SEAPATH. First is that we write test reports. A test report is just a human-readable document, here we have a PDF on the right, that display all the tests that I described earlier, and correlate them with the name, so description, an ID, and their status on the current build of SEAPATH. The goal is to organize all these tests in categories. So, for example, you have a security test on the bottom, and by machines. We have many machines in the cluster. We want to test every machine, run all tests on every machine. Then we have compliance matrices for a given specification. I spoke about the ANSI BP28 for the cybersecurity earlier. They have many requirements, 80 requirements, I think. And we have tests for each requirement. Some are very simple. On the right, you can see that some are just one test, and others are really complex and which have 10 to 20 tests. And so by building this type of compliance matrix, we can see really short what requirements are okay and what requirements should be future works. Now I have described everything. Let's talk about the effective CI implementation, how we do that, in fact, on SEAPATH. All SEAPATH code is available on GitHub, so we just use the newly GitHub Actions to launch our CI. The goal is to test all the code, so we will learn that on every pull request that we do or that a contributor do on SEAPATH. Everything is sent to a cluster from SEAPATH that is currently here in RTE, or we have another one at our organization at Savoir-faire Linux. The software must be configured correctly, so for SEAPATH to be built, and all tests must be launched and passed to ensure that we meet all the requirements. In terms of maintainability, we also launch additional linters. We have SonarCube on the repositories that are handled by SonarCube, or a shell check or Ansible lint for a repository with bash code or Ansible playbooks. For the way we write tests, we use a little test framework that is Cookinia. That's just a very simple tool for a Linux validation framework. The idea is just to give a little abstraction over the system to write tests. It's really easy to deploy because it uses only shell code, not even bash. And it extracts the results in XML or CSV. That's the way we use it to build our test report after that. And so it let you write some tests, like you can see here. Is a user created? Does a directory exist? Is a service running? All sort of code. That's not that seems not so hard, but that avoid us to have to write complex commands every time we want to test something. We just write, let Kukinia check if that service is running. Also in terms of implementation, today we have CI running on the Debian part of SEAPATH. We choose to do that here first because we can flash all the hypervisor with a Debian version, and there is no compilation needed, and we don't have to flash the CI every time we run a pull request, because we can just configure the Debian version. That's how it is built on the SEAPATH project. We use Ansible to configure that as infrastructure as code. All the SEAPATH project is configured through Ansible. The Yocto version is also, but much more things are done in the Yocto compilation. And the tests are run and deployed with Ansible as well, which also is used to back up the data, the test result, and later we can build the report. Here is it, the entire CI, just to wrap up things. The first thing is that someone launch a pull request on GitHub. All sources of the pull request are downloaded on the SEAPATH cluster on a management machine, which launch Ansible for every machine to be configured. We launch Kukinia to have all tests wrap up, which are backups by Ansible. The PDF is generated, and it is posted on GitHub for everyone to see. That's really important to us, because that means that every person that wants to contribute to SEAPATH can come, send a pull request. After it's approved by a member, the whole CI comes, and the person can see if all tests pass and what is not done properly. We have some work in progress and to come, of course. So I write it that we have to deploy a CI for the Yocto version. This is in fact done since 3 or 4 days, so before the creation of the slides. We have a machine that runs at Savoir-faire Linux for the Yocto version of SEAPATH, and that basically uses the same principle as everything that I described on Debian. Another thing that we have to do shortly is to add a robustness test. I don't spoke about this test in the list because it's not done yet. The idea is just if something is wrong on the cluster, how can we respond to it? If an hypervisor crashes, is the virtual machine restart correctly? If a machine crashes, if a virtual machine crashes, if a cable is unplugged, what are the effects on the cluster, and how can we test that? That's a bit hard to test automatically, because of course we can just unplug the hypervisors, but we don't want to do that all the time, every time a pull request is updated. So we have to work on that for now. So that's it for my presentation. If you're interested in the project, you can go and see it on GitHub. It's right just there. If you are interested by Savoir-faire Linux, you can come on our website and discuss with us. Many people are interested to discuss about. And thank you for your attention. If you have questions about the project, the company, or whatever, I can answer many questions. Yes?
Thank you for the presentation. A quick comment. I think it's very impressive how you can help industrialize our work, the agility, etc. So thank you for that. I'm not. I will look at the VM part in the sense that imagine that I have a algorithm, a logic for automate. I'm wondering how can I deploy in the SEAPATH as it is now. Probably we'll talk later for the detail, but what are the requirements for the logic? Is there, for instance, the specification of the clock? You did mention, you know, the clock for the logic, for instance. I suppose it depends on the capacity or the machine, the resource we have to run it. Let's start from
yes. So concretely, what we provide with the SEAPATH project is the mainframe, that as I described, and a basic virtual machine. So you can run your code in it, and if some manufacturers don't know how to create a virtual machine, we can provide one with SEAPATH. All the question with the specific hardware is so SEAPATH is only software, and the goal is not to provide a specific hardware for SEAPATH. So this is the customers of SEAPATH must run the project on a hardware that can handle it. And it's, for example, I will take the example of RTE. For example, if they want to run SEAPATH, they will install hypervisor on a substation and say, okay, we have such a hypervisor. We can have this clock. We can have this network, for example. That's not technically not the SEAPATH goal to provide this type of information on the hardware. Okay, if there is no other question, I will end up here. But if you want to discuss with us, there are 3 other members of Savoir-faire Linux that work on SEAPATH, and we will be happy to discuss that with you. Thank you.